So welcome to this panel, which is dealing with the transformation from the Internet of Things to the Internet of Energy. I think we're all familiar with the Internet of Things and how that has served as a vehicle to transform the way we do business and made for a much more efficient set of economic interactions and business models. The advent of distributed sensors, the development of the internet infrastructure, communications protocols, technologies, have all led to move the Internet of Things into the Internet of Energy. I think we've seen evidence that the Internet of Energy can in fact make energy systems, renewable energy systems in particular, much more efficient. All the way from managing sources, understanding what resources for various renewable energies are available when, managing those resources as they integrate with utilities, to managing consumer use of electricity, in the home sensing, using information about how consumers are using electricity to provide more comfort to users at less energy use. So lots of ways we see the Internet of Energy already impinging in business models and in our lives. But I think there are a lot of interesting questions around whether or not, given the infrastructure that's there, the sensor capabilities, has the Internet of Energy delivered what it might? What could it do that it's not doing already? I think there are lots of opportunities, certainly that we can all see. And so we've put together a panel of experts in various aspects of the Internet of Energy who can, I think, give us some very interesting perspectives on different enablers for having the Internet of Energy make a difference, giving us some insights on what those key enablers are. What are the roadblocks? What are we missing? What are some of the new business models that might come to be? And so I'm really excited to hear from our distinguished panelists and then to have a conversation about where we might go. So let me very briefly introduce the panelists and then invite each of them to make a couple of brief opening remarks. So if I go from my immediate left on down to the end, first panelist is Deb Frody, who's the Global Executive Director for GE Ecomagination. She leads GE's business strategy and commitment to accelerate technology development that increases consumer productivity and acts as a driver for clean energy solutions. So, a lot to offer in this area. Next, going down the row is Michel Croissant, who's Executive Vice President for Strategy and Innovation at Schneider Electric. He's worked very broadly within the power sector, beginning in the uninterrupted power supply area. He's done operational management roles in manufacturing and marketing, and served as strategy and IT director. So again, lots of expertise relevant to this area. Then Heinrich Von Pierre, who is former CEO of Siemens Corporation. As such, he's had a very broad view of the energy industry. He's also served as an advisor to the German governments under Schroeder and Merkel. So he offers a very interesting perspective on the government technology side. And then, last but not least, on the end, pleased to have Gordon Feller, who's the Director of Urban Innovation at Cisco. Gordon, as a Director of Urban Innovation, he works with the Internet of Things focused on initiatives with key Cisco customers and partners. So with those brief introductions, I'm going to ask the panelists, beginning with Debbie, to say a few opening words, and then we'll begin a conversation.
Great,
Debbie?
thank you. So I'm delighted here to be with all of you. I do lead, I thought what I would just share quickly is an overview of Eco-Imagination and also what GE is doing relative to the industrial internet and where we are currently. So first and foremost, Eco-Imagination is about, it's a commitment and a strategy to developing cleaner technology solutions that help our customers maximize resource efficiency, economics, and environmental performance. We are celebrating our 10th anniversary this year. We launched the program back in 2005. Eco-Imagination today has generated over $180 billion of revenue, proof point that our customers value intelligent, efficient solutions to help their business. We've also invested over $15 billion in just R&D and innovation for Eco-Imagination technologies. From an industrial internet perspective, GE 4 years ago made a $1 billion commitment to the industrial internet. Our vision was to have all of our industrial assets connected into the internet through sensors and software and communication network that would allow us to create big data and analytics that we could drive bigger outcomes for our customers. Outcomes like no unplanned downtime, preventative maintenance, improved productivity, and today that vision is now in the now, and we have executed. We have a software center in San Ramon, California, 1,200 data scientists and computer engineers working on the industrial internet. GE has now a software platform called Predix, and we have over 40 industrial applications on that platform today. And it will continue to grow. So we are just getting started and very excited about the opportunity to drive even bigger outcomes for our customers.
Thank you very much. Michel.
Thank you very much. I'm very pleased to be with you also this afternoon. On Schneider Electric side, we started a big transformation journey because we position ourselves now as a company helping our customers trying to do more while using less of our common planet. So this is a big change because this is a convergence of this OT world with the IT world, obviously, made possible by the Internet of Things story. So it has started in the industrial world, and now it's accelerating everywhere, and obviously in the energy world, and then in the smart city context. So big acceleration, and the main thing we need to understand, this is not possible without a strong collaboration with the partners and with customers, obviously. So we do partner with a lot of IT companies, Cisco, obviously, Microsoft or IBM, on different aspects. And we do partner with customers because it has to be clear this is all here to make this complex connection between IT and OT very simple to customers and easy to use. This is absolutely necessary. So big transformation of everybody, including us, and we start comparing ourselves, which is really new to the software world. When we make the addition of all the software development people we have, we start appearing in the ranking of the software company, which is totally new. So understand that big change and big evolution in process.
Thank you.
Yeah, thank you, Mr. Chairman. You introduced me as a former Siemens representative. So I'm not talking, my three colleagues talking about their company. I know that my, successors don't like if a retiree talks about the company. So I will not talk about the company. I talk as a private person here. And I try to avoid to fulfill the observation of a German humorist who once said, everything is said, but not yet by everybody. So during the last days, I asked some of my colleagues, some of my former colleagues, some of people that are still active in the business, what they think is the Internet of Energy. And much to my surprise, I didn't get any satisfactory answers. As a matter of fact, they didn't know very much about the Internet of Energy. They knew a lot about the Internet of Things, but not about the Internet of Energy. And this is the more striking because Germany is widely seen as a front runner in this regard. In the past, only a few words have managed to become part of the English language. One is kindergarten, another one is Angst, and a third one is Energiewende, turnaround, energy turnaround. The disaster of Fukushima in 2011 caused an abrupt change of the energy policy in Germany. The last nuclear power plant will be independent of any safety questions closed by 2020. And also, in addition, hard coal and even brown coal, which is very important for Germany, is maybe almost 30% of power supply now, is under strong criticism. And what we experienced in the power industry is a remarkable shift from central power generation towards a more distributed generation, driven by the increasing share of solar and of wind power and biomass. From an international perspective, the German Energiewende is both. It is a matter of admiration for some people, and for other people it is a matter of skepticism. Admiration because of the target to achieve 80% of renewable energy in 2050, and also admiration the rigidity and consequence which is being implemented in Germany. And by the way, these are, in my opinion, typical German attitudes, as you could see it also from our football team. So skepticism because of the high cost amounting to more than 20 billion euro subsidies per year, and this not only for 1 year, but maybe for the next 20 years. Skepticism because of the slow implementation of a more, how should I say, dynamic and responsive power system that can cope with the volatility of PV plants and wind turbines. On a windy day, it was the 9th of January this year, wind power contributed more than 30,000 megawatt to power supply. The next days, it was gray and no wind, and then all the conventional plants had to take over from the renewable part. So this is, of course, a big stress to the grid. And it put the power system under a severe stress. And it clearly demonstrated the need for more interactive and integrated solutions to balance the conventional and the renewable power producers with consumers. And when we want to secure a safe power supply, a lot of things have still to be done to make this Energiewende in Germany really a matter more of admiration and of a success story.
Thank you. Gordon.
Well, we've, as a company, we've learned over 30 years some things about the internet that are applicable to the Internet of Things and especially to the Internet of Energy. And I'd want to emphasize a few of those lessons that have immediate applicability to what we're going to discuss today. One of those lessons is that when you have distributed assets, whether it's generating assets or computing assets or communications assets, there is a challenge in the complexity of that can be solved by some simple, elegant solutions. Not every complex problem requires a complex solution. And we've attempted in the 30 years of the development of the internet, and we've been at the center of most of the innovations that have tried to cope with the explosive growth, thanks to all of your smartphones. We've now been able to manage that intermittent demand as well as intermittent supply. And we think there are some lessons that we'd want to apply those lessons in the Internet of Things, and especially the proving ground of the Internet of Things, which is in the energy sector. If we are talking about the Internet of Things and we're not able to make that applicable in the energy sector, which is, the largest segment of most economies in the world, because it's expensive. Even with the price of oil dropping, it's still a very expensive thing to supply cool air or heat or light to any space, a space where in this room, most of it is empty. So we're interested not just in connecting things, but in capturing the insights and then being able to act on the insights that comes from having connected things. Because otherwise it's meaningless. Connecting things, having machines talking to machines is beautiful, but it has to result in an insight that then can be the focus of action. And without that, it's just nice technology. So we want to tap the inherent power of what we think is the ultimate natural resource, which is the data. And the data in the energy universe is rich and untapped. It will enable us, when we do it right, to utilize our energy assets better than we do, balancing loads in networks, in grids, and energy systems better, transacting multiple directions, not just producer of energy and consumer of energy, but many different directions of transaction that haven't been possible before. And those systems, those energy systems, can become more adaptive. They can deal with intermittent power and a lot of other challenges. So we think the business model in the energy industry is going to change dramatically, and it is already. And distributed generation is really one of the next big disruptors to the energy model that large utilities have traditionally built their business on. And so maybe that would be an interesting area for discussion. Back to you, Bob.
Good. Thank you very much, all of you, for interesting perspectives. So let's go back. You said this disruptive models here, and talked about distributed generation. What are some of the barriers for getting this Internet of Energy to help us out, right? So where do we see it? Do you want to start with that, Gordon?
Well, we can talk about, politics and government and the barriers of the regulator not understanding the technology, which is a frustration for us and a lot of our customers, but I'll leave that to somebody who's having to cope with government officials on a regular basis. We can talk about the business challenge of helping to manage energy flows in and out of enterprises and in and out of buildings, and that's certainly in Schneider's wheelhouse. But an area where Deb and I are focused, two companies that collaborate very closely over many years, is creating a common approach that companies who are building the Internet of Things and the industrial Internet are now working together to do some remarkable things to create global common open standards of the type that fueled the growth of the Internet. Because if we're not talking in the same language, we're not talking in the same protocol, even if we have different types of data coming from different types of pieces of the energy industry, if we don't have that common framework, then we'll be a Tower of Babel, and we won't be able to take advantage of the full value and potential. Maybe you want to say some things about what the Industrial Internet Consortium is all about, why it came about.
Yes, so it started, I mentioned about the Predix platform that GE has developed. So we're creating industrial applications, building those, managing those on Predix today. Every GE industrial machine is now Predix ready. And so, the industrial internet, however, is much bigger than just GE's assets and our customers' assets. Today the industrial internet is over 10 billion assets. And so it made us realize, as we're contemplating opening up Predix, so any company could in fact develop their own industrial applications on our platform, that there needs to be more standards. We need to be coming together. This is still the early days. And so GE, Cisco, and 3 other companies were the founding companies to develop the Industrial Internet Consortium, really bringing together industry to talk about common standards, as Gordon mentioned, around open sourcing, around security, around architecture and communication. And so now, you have a room of over probably 50 people that are made up, or 50 companies made up of the consortium coming together. They're competitors as well, but to really move the industry forward with standards, consistency, so we do the right thing around the industrial internet and we can continue to grow, because the opportunity will be globally transformational to industry. And so we just want to make sure that we get this right.
Oh, Heinrich, you wanted to say something, and I'll
Make
come back to
a
Michelle.
remark. I think it's very interesting to see how now companies work together, like GE and IBM and Cisco in this, what you described in this consortium. And in the past, my observation is they were not competitors at all. They were supplementing each other, cooperating. But in my opinion, there is a dramatic change in the competitive landscape now. Because, of course, there are these traditional suppliers of the infrastructure, like GE, like Schneider, like Siemens, gas turbines, distribution system, power lines, and so on. And now on the other side, there come the others who want also eat the cake. And they come from the, you explained it very nicely, from the data side. Big data, how to handle these big data, and even more important in the future, how to analyze these big data. This huge amount of data, I have heard in a platform, in an offshore platform, on an oil platform, there are 50,000 sensors. Yeah? And if you, well, collect every minute some data, you see how huge these amount of data will be. And now the question comes, who will analyze it and who will take then the necessary steps to make a new business model out of it? And what one can foresee is this is now a friendly cooperation in this consortium. But what I foresee is a big fight between these companies coming from the data side, like Cisco, like Google, like IBM, like SAP, and others, and the traditional suppliers like GE, Siemens, Schneider, Hitachi, and who name it. So, and I think there will be a much bigger cake that can be distributed in the future than it was in the past. But who will be finally the winner? This is a very open question.
We'll see if the public is the winner in the end.
Just one word. I cannot agree more with the need of common standards to develop the solution, but I think we need to say one word here. This is simplicity. We need to fight for simplicity because we will be overwhelmed by data. And the question is, what do we do? And at the end, we need to realize that putting all this data together brings a lot of complexity, and our job is to make this very simple. As long as we'll not be able to bring a real customer value, we'll not be able to invent a new business model and to make a real business out of it. So simple, simplicity, easy to deal with, and etc. are the key words for me.
So we talked about simplicity. Data analytics has come up. The problem of all this data on an oil platform or some other energy platform comes up. So how well is data analytics keeping up with the speed of deployment of sensors and interconnects and so on? What do you need from data analytics? Who's going to do it? Are there new partners to bring to the table there? How's that happening?
Well, I'll start from the vantage point of Silicon Valley. What we need is the engineers who are trapped inside Google working on delivering advertisements in better ways to actually focus on the analytics problem. Because they're paying those engineers so well that we can't possibly recruit them to do the things that humanity needs, because delivering ads, to my mind, is not exactly a high priority. But anyway, that's just an opinion. So big data has to result in little insights that will make decisions possible. And in a smart city context, that means, big data empowers citizens to be smart citizens, to do the right thing when it comes to the micro decisions. When am I going to park? Where am I going to park? Or am I going to take public transit? Or am I going to telecommute because I don't even need to move myself to get my work done? So data in motion is very powerful. Data at rest really doesn't have much value. And the data in motion in this case has to be the meaningful, useful data, because none of us are in a position to consume and utilize the raw data that's coming off an oil platform. But there are thousands of people, safety engineers, process engineers, you name it, who want to have access to those 50,000 sensors, but only the meaningful information that's going to be streaming off that platform to somebody who's sitting onshore trying to help remotely manage. So that picture of big data that becomes little insights that are useful for action hopefully provides a framework for talking about what's useful for the energy industry, because there's big consumption of energy big data generated by energy users and consumers and distributors, but where is the little insight?
No, we need to get it down to information you can operate on, right? Actionable information.
So
Heinrich?
what we
Yeah?
will see, there are a lot of new business models which will come up, and maybe you mentioned the Silicon Valley, these very fast and quick people that in the startup companies, they have now new chances. Of course, we have already some more or less traditional business models, almost traditional. This is remote control of a wind turbine, for example, or of a gas turbine, and the control center can be in the US, it can be in Germany. A very important and, in my opinion, decisive device will be the smart meters. Smart meters, without smart meters in industry and especially in, let's say, in private homes, this is what we call Energiewende. That means the balance between suppliers and distributed suppliers and customers will not work. Because we need this really then to tell the customer now, this is now a good time to use your refrigerator, or in the industry we can say now you can use more energy or less energy. Really to balance the Energiewende is only possible if we have this good and very flexible measurement via smart meters.
So Gordon, you mentioned just a second ago smart cities, which is, I think, in everybody's mind an important piece of an efficient energy future. But that brings in the idea of other systems besides energy per se. There's a transportation system, which you mentioned explicitly, a water system. How do we connect the Internet of Energy with those systems, take those data and integrate those into energy decision-making processes?
Well, some cities will move earlier in energy because they've traditionally operated their energy business as a city in a way that hasn't been very efficient, and that's created a huge business opportunity for all the companies up here, right? So the inherent inefficiency of the way that cities are using energy is a huge business opportunity, not just for cities who are municipal utilities or own municipal utilities, but for all of the players in the cityscape. And our sense is that those cities that move fastest are going to be cities who probably start with the energy picture in mind, even in a moment in history where energy prices may drop because the price of fuels will drop. It won't make a big difference when cities are looking at their total energy matrix and trying to figure out what they can do to incentivize all the actors in the system, private sector, public sector, independent sector, to play the energy efficiency game. But the challenge will be for those cities to have access to the tools, which are data tools, which are monitoring tools from a company like Schneider, which are the meter and the advanced metering infrastructure companies like Itron that are working here in Dubai. So my guess is that those cities who act fastest on the energy efficiency front are going to find themselves very early to the Internet of Energy itself. That's their path in. And they'll be then moving to their water and their transport domains to try to take advantage of what they've learned in the energy space.
Michel?
Yeah, definitely, because the energy part is a key brick of the smart city overall ecosystem, you know, because we have to remember that 40% of the energy electricity is consumed in the building, and if you consider that municipalities and cities are owning a big part of the public building administration and etc., the electricity bill is very important for the cities. Would it be for their building or would it be for the public lighting? So I think the early adopter in the smart city of the electricity part will be the trendsetters for the more global smart city stories. This is what we see on our side, at least.
So we have some questions from the audience. I want to hit some good ones that we'd actually talked about earlier and haven't hit on. One is cybersecurity. I think there's a lot of opportunity as we put all of this infrastructure out there and we network together, but there's also some concern about security of the data that flows across this network. What are your thoughts on how do you protect this infrastructure against cyber attacks, while we still try to benefit from the positives?
Well, cybersecurity is a totally new concern, domain, where we need all together to learn and to progress together, seen by me. So it starts by the data ownership at the beginning, where I think we need to go beyond this simple concept, because the real issue is what we do with the data. I'm not totally interested by all the people knowing at what time I get up in the morning, at what time I take my breakfast, and etc. But if people are coming to me saying, if we allow to borrow this information for you, we are able to bring you some value, I'm ready to consider. So this is the first aspect. The second aspect is the cybersecurity, or the risk, the threat in the transmission. And then we can make big progress, and we're started as manufacturers to make big progress in protecting the different devices by themselves. And then the IoT, the big data things, come as an help also here, because by understanding the behavior of the people and the noble behavior, the abnormal behavior, you can now detect intrusion and to better protect yourself around intrusion. So this is a new domain, obviously, but that is progressing quite rapidly at the same pace as the new usage of Internet of Things. So we just have to be aware and bring the right solution. But on all these aspects, I'm not saying that in Internet of Energy or Internet of Things, smart city, the main idea to convey is that technology is ready for me. And the main topics to address hurdle challenges are more on the business models, the behaviors, the collaboration between companies that are the key for the future.
So we've talked about a lot of opportunities here. Where do you put your money and your investment first? Where do you see what do you see as the technologies that offer the biggest return on your investment, or the application spaces that have the best return?
One quick answer would be, we put it where the customer demand is. So listening to the customer every day, and what we're hearing is that their biggest concern is utilizing the existing assets that they've invested in already. So in our case, they own wired and wireless networks that were expensive, and they're not fully utilizing that. How can they connect the devices, the systems to that network that they've already paid for to fully utilize the investment? In Deb's case, how do you take the existing power generation assets and turn them from 30% utilization to 60% utilization, which would double essentially the productive value of that investment to the owner of that asset? So when we hear the customer demanding better value for their dollar, better utilization of their assets, they're also talking about real-time knowledge. They want to know now, not a week from now when you've done an analysis, how well is it performing? So that real-time information of their existing asset to utilize their existing investment is what we're hearing constantly from the customer, and that's the area where we're investing in new technology.
All right, Debbie, do you want to say something about?
So I agree with Gordon. You know, it's the customer demand. GE is a diverse portfolio. We have applications across the entire portfolio: oil and gas, power gen, healthcare, you name it. But Gordon is right. You know, we can make such an impact with a digital layer on an existing installed base. And let me just give you some context. So we have an industrial application for our wind turbines called Power Up. So it harnesses the industrial internet. It's a digital layer. It's a software layer that allows us to increase output. So our customer utility, European utility E.ON, has deployed Power Up on its 469 wind turbines today. With that digital layer, they are able to have an increase of 4.1% of clean energy output. So that's equivalent to installing an additional 19 wind turbines. So they don't have to go through installing that additional hardware, its resource productivity, that digital layer is giving them 4.1% more. Their operation, their asset is much, much more efficient. And those numbers, whether it's 1, 2, 3% sounds small in improvement, it's massive. And you think about the impact of a customer's operation, that gives them improved margins. And you look at that on an industry basis, it's huge. It's absolutely huge. So transformational.
Okay, so we're running near the end of our time. I want to give the panelists each a chance to make some final comments, so we could, again, maybe start with Debbie and go down the row.
So we are really, really excited. You know, GE is a 130-year-old company today, and we see the industrial internet as being absolutely transformational. Our chairman and CEO, Jeff Immelt, now describes the company as an infrastructure and an analytics company. It is the merger of hardware and software. The physical and the digital worlds are merging together, and that is allowing us to create new value for our customers, driving bigger outcomes than ever. And it has been very transformational in how we do that for our customers, and it's a very, very exciting time. And we really believe that from an eco perspective, the resource productivity, the fuel savings is going to be incredible, and it'll be fun to watch.
Michel?
I don't know if you remember the discussion we were having 5-10 years ago, saying we are going to be short of resources, of fossil resources. It was all about fear and negative feelings. And today, this is totally the opposite. We are all positive, and we see a new world coming, and with a lot of opportunities, which is obviously a lot of coming challenges. But I think the final word for me would be, let's be energy optimist.
That's a good one. Thank you.
I think it's an interesting time, a time of transformation. We will see new players coming up, and the old players fighting not to lose too much ground against the new players. And I think the Internet of Energy will come, but maybe it will also be disruptive, as you said, but it will not come so fast as it was our experience with the communication and information technology. Because I think you mentioned it was absolutely correct. There are big investments. There are investments in the infrastructure, investment in power plants, investments in distribution systems and so on. And all this will play a role also in the future. And therefore, this will take time until this Energiewende, Internet of Energy will really be implemented. But with new chances, new players, and a lot of risks for the old players.
Well, we're in this amazing period right now where there are 1,000 experiments in this domain underway, some of them in very small workshops. You know, the startup model of a young company of 2 or 3 engineers who are creating disruptive technology that may never see the light of day because the innovation cycle may break and they won't commercialize that technology successfully. We hope they will. Disruption will be good for this industry. The energy industry is ripe for a massive overhaul because those fixed capital expenses are frankly a drag on the global economy, and there are better ways for us to utilize that capital to enable us not to build more generation, but to utilize the existing generating assets that we have in incredibly better and faster and cheaper and greener ways. And my hope is that as these science experiments that are happening in 1,000 different locations begin to emerge, cities like Dubai and Abu Dhabi and governments like the UAE will become early adopters, because this is an environment where the government has basically decided they want to be a test bed. And my prediction is that next time we come here next year, there'll be some interesting things happening. And those little pilots like Dubai and Diwa have right now of 1,000 smart meters will show that there's a potential to scale and replicate and transfer that.
Okay. So one last question then. That's a nice optimistic statement about next year. Heard a lot of interesting opportunities ahead. What keeps you up at night thinking about what might get in the way of all this progress? Do you have a big fear out there? What do we have to look out for?
Trust and collaboration between actors, because by putting all effort together, creating alignment between actors will create momentum to start.
And my biggest fear is that we'll miss a moment, because we're not ahead of the transition, we're behind the transition, that we miss a moment of opportunity because we're distracted.
I have no fear. I'm an optimist. We have always find solutions for problems, and this will happen in this case as well.
Yeah, I agree with Gordon. It's being able to go fast enough. How fast can we go? Because the opportunity is really transformational in front of us. So it's the speed.
Well, I'd like to thank all the panelists. It was just a great discussion and conversation, a lot of insight, so thank you very much.